Hey, Honors Geo students. Welcome to summer school with Rosenwald. I'm just trying to set up the notes here for everybody, but I just realized that the numbering was a little bit off, so I want to make sure I clarified something with you. We're going to be working through all different units. We have 12 units in this semester, and then we're going to do 12 more units next semester. These notes are not always in the correct numbering order when you look at the sheets. So, for example, when you look on here, you'll see that it actually says objective 2 right here, but that's actually not the case because of the fact that we pulled information from different things and we went ahead and kind of rearranged the order, but the order on the Schoology page is actually correct, okay? So just keep that in mind as we're working through things. I'm going to go ahead and minimize myself here to get myself out of the way, and then we will go ahead and get started on our notes. Okay. So to start us off here, the first unit that we're going to be working with is orders of operation. So the first question we have to ask is, well, what are the orders of operation? Why do we have them? We have them because it's a universally accepted order that we're going to actually go through and do mathematical computations. If you in America are doing the order one way, and I in China am doing the order a different way, and we're trying to collaborate and do mathematical operations, if we don't do it the same way, people die. And so, that has happened before where, rockets have exploded because somebody forgot to do a computational, some sort of computation in one place, and over in another, they were using a different system for, mathematical computations, and they weren't on the same page and people died. So when we're doing orders of operation, the question is, what are the orders that we're going to actually follow? Well, we use a little phrase called PEMDAS, but there's a few things to add to this, okay? PEMDAS is actually going to end with LR. Now let's go through each one of these. First thing is P, which stands for parentheses. Now you'll see later I'm going to change this, but we use parentheses as the P. The next step that we do when we're doing orders of operation is we work on the exponents. After that, we're going to work on multiplication, and then we do division, addition, subtraction, and then I bet you can guess what the L and the R are. They actually stand for left and right. And so what this means is that as you're doing certain computations, you're going to find that we're going to go from left to right, and I'll explain when that is, okay? So let's jump into grouping symbols. Now, we're going to actually use, when we use the letter P, we don't just say P for parentheses, because the fact is that there's actually a number of different groupings that we can actually use. So it's not technically parentheses, it would be grouping would be the first step. Well, here's our first grouping symbols. We have parentheses. These are the most notable ones. You're going to see these a lot. Parentheses are always going to be worked from the inside out. Usually wrapped around parentheses, so you'll see parentheses first like this, and then you'll see the brackets around those parentheses. These are called brackets, okay? After that, we move on to braces, which then you'll see parentheses, and then you'll see brackets, and then around that you'll see braces, like so. Okay, and again, you always work from the inside out as you're working those. The next one is when we have the double lines, there's nothing in terms of like the position at the top or the bottom. It's just two straight lines. This is our mathematical way of saying absolute value. And so what absolute value means is we're asking for, it's always going to be a positive answer unless there's like negatives on the outside or something like that. But the definition of absolute value is the distance that a number is from zero. The next one is square root. Square root is basically a symbol that says what number is multiplied by itself that's going to equal the given value. So for example, if I was to say like the square root of 4, what number got multiplied by itself to equal 4? Well, that's simple. That's just 2. Okay. The last one, we say question mark over question mark. This implies that we're saying it's a fraction. And when we're working fractions, believe it or not, there's an order that we actually go through and do this. We will always work the numerator, which is the top, and then we're going to work the denominator, which is the bottom. And then from there, we're going to simplify the top to the bottom. Okay? So now, working on number 3 here, it says, what's the difference between these given expressions? You can put these into the calculator exactly as you see them, and you'll notice that there's going to be a very big difference. The first one, when we look at it, that -2, that's squared right here. What does that mean? Well, the way that we read that is it's saying -2 times -2. That's what that square implies that's right here. And so that means we're doing negative times a negative, which is going to give us a +4, which is a little bit different than this one right here. This one is saying, when you read it, it says the opposite of 2 squared. That's right as the opposite of 2 times 2, which is going to equal negative 4. So the parentheses definitely made a difference there. When we look at the next one, what we see is that we've got a negative on the outside, and so what this says is the opposite. And then we say right here the opposite of negative 2 squared. Well, we just figured out negative 2 squared. That's up here, right? We know that that's going to equal 4. So what this reads as is like the opposite of negative 2 times negative 2, which is going to equal just negative 4. Now again, if you're not using parentheses appropriately, you're going to get the wrong answers. And you're going to see this when you get to higher level math, that the parentheses actually make a very big difference. Let's take a look at these, okay? So if I just put in a negative 2 squared, you can see we get a negative 4. If I put in a negative 2 squared with the parentheses, remember we said that this is negative 2 times negative 2, that's going to equal positive 4. And if I say the opposite of negative 2 squared, okay, that we can see is equal to negative 4. They look the same, but they're all completely different, okay? All right, so let's get down to the hard stuff here. What we're going to be doing is we're going to be practicing doing the orders of operation. We're going to go through this checklist here. Let's talk about this checklist again one more time. We're going to make a slight modification. Where we see P, which stood for parentheses, we're going to actually call this G instead, which is grouping symbols. In addition, when we see the word L and R, when we see the L and the R here, what this implies is that if you ever have two operations paired up together in the problem, you're always going to work them from left to right. So if we have multiplication division in the same line of the problem, we always do those from left to right. If we have adding and subtracting together in the problem, we always do those from left to right. Okay? So let's jump in. Let's go ahead and start doing these. All right, and we're just going to kind of do a little checklist, okay? So first thing, do we currently have grouping symbols in this? We do not, okay? Do we currently have exponents? We do not. Do we currently have multiplication? We don't. Do we have division? Yes, and we had division more than one time. So what we're going to do is we're going to work through these from left to right, okay? So we're going to do these at the same time. And what we have here is 2 plus 1, and then we still have minus, and we still have, actually, we have more division here. We have this 15 divided by 5. 15 divided by 5 is equal to 3. And so now we continue on. We look at this checklist and we say, all right, we did grouping, exponents, multiplication, we went through division. Now let's do adding and subtracting. You can see in this problem when we get to adding and subtracting, we have both adding and subtracting in this. So again, the rule is we're just going to go from left to right. So we'll go left to right straight through this then. And we're going to have 2 plus 1, which is 3. And then we have 3 minus 3, which is just 0. And this is our final answer. Okay? All right, let's start over here. I'm going to show you guys two ways to do this one. I'm going to show you the conventional way that you guys probably are comfortable with. And then I'm going to show you an advanced way that you're going to want to get used to for higher level math later on, okay? So looking at this first thing here, we have a fraction. And remember, when we have a fraction, that's classified as grouping. And we said when we do fractions, we're going to do them from the numerator first. We're going to do the top first. Then we do the bottom, and then we simplify top to bottom. So if we go ahead and do the numerator first, that's our top, we're going to put these together, and we're going to get 4 plus 1/2, which is 4.5 or 4.5, okay? When we do 2 minus 1/4, that's 2 minus 1/4 is 1.75 or 1 3/4, okay? Now, this is where you might want to use your calculator for something like this, but we're going to get used to not using the calculator as well, because in later math, you're not going to be allowed to use a calculator, okay? But if we simplify this, we get 18 over 17. I'm sorry, 18 over 7 for the final answer here. Now, how can I get there doing like the actual math without a calculator? Well, there's a couple of ways, all right? First of all, let's look at this number right here. And if I want to write that as a fraction so that it's got the same denominator as this 2 right here, think about what you need. You need some number divided by 2 so that it equals this 4 that's right here, right? Well, the only number divided by 2 that's going to equal 4 is going to be an 8, all right? On the bottom, to work with this 1/4 that's right here, we need this to be a 4 on the bottom so my fractions can work together. And I need to know what number divided by 4 is going to equal 2. Well, the number that's going to be divided by 4 that's going to equal 2 is going to be 8. 8 divided by 4 is equal to 2. If we continue simplifying this, we're going to have on the top 8 halves plus 1 half is 9 halves. 8 fourths minus 1 fourth is 7 fourths. Okay. And now we do a process called keep, change, flip. So we do keep the 9 over 2. This division right here is going to be written as division, so it's going to be 7 over 4 after that. So 9 halves divided by 7 over 4. And then we do keep, change, flip. We change the fraction afterwards. We go ahead and flip it, and we're going to get 9 over 2 times 4 over 7, which is 28 over 14, which if I reduce that down, divide everything by 2, we're going to get 14 over 7. So that's the simplified answer here. Oop, something happened. Hang on. I said 28. Ugh, God, you could tell how my brain is in summer mode. This is 36. Okay? And then that's going to give us 18 over 7 when we simplify it. Now, that's a long way to get there. So this is where I'm going to show you the advanced way of getting there. Okay? When we have 4 plus 1 over 2 divided by 2 minus 1 fourth, what we're going to do is we're going to actually take everything in this and we're going to multiply everything by the least common denominator of those complex fraction parts, the 2 and the 4. So the LCD of 2 and 4 is getting the least common multiple. That's what LCD is. So if we go through multiples of 2, they're 2, 4, 6, 8, right? And if I do the multiples of 4, they're going to be 4, 8, 12, and so on. And the least common multiple of these happens to be a 4. Okay, right here is the 4. And so what that means is we're going to take and multiply everything in this problem by the LCD, which is 4. So what does that mean happens? Well, if I multiply everything by 4, this is going to turn into 16. Half of 4 is equal to 2. 4 times 2 is 8. And 4 times negative 1 fourth is negative 1. My complex fraction is now gone, and if I simplify this from here, we're going to have 18 over 7, which is the exact same thing as what we had here. So try to use that advanced way. This is the fast way of getting rid of complex fractions whenever you run into those, okay? All right, next ones. We're moving on to level 2 questions. We're going to kind of speed things up here a little bit, all right? So we see square root. We see a square root symbol right here. That means we're going to do everything on the inside first because that's the grouping that's going to happen there. So we're going to go square root, and we'll go from left. We'll do the multiplication first. So we have 10 plus 39. Okay. On the bottom, I'm going to have 4 minus, I'm not going to do too many steps at once here. On the bottom, we have the 6 divided by 2, which is going to equal 3. Okay. Remember, we don't do subtraction here before we do division. Okay. We're going to do the division first. Let's continue on. So from here, we're going to go ahead and simplify. We're going to have 3 square root of, let's go ahead and put these two together. So we're going to have 49. And then let's put the denominator together. That 4 minus 3 is going to give us a 1. Continue from there. We have 3. And remember, the square root of 49 is saying what number got multiplied by itself to equal 49. Well, the square root of 49 is just 7. And then we have divided by 1. Excuse me. So we end up with 21 divided by 1, which is just 21 for the final answer. Okay. All right. Letter B. That's square that's on the outside. Oof. What does that mean? Well, we don't have to worry about that exponent on the outside yet. Remember, we work on the inside of our parentheses first. Okay. So what this means is that on the inside, we're going to do this part first, which is going to give me an 8. We're going to do this part first, which will give me an 8. And then we're going to have plus 1. And remember, all of that still is to the second power. Let's just continue working with this, okay? If I continue to simplify this, we're going to have 8 divided by 9, which will then be squared. And then from there, we have 64 divided by 81. So that's just our left side of this. Let's continue with the right side where we have more parentheses happening, okay? Inside of our parentheses there, we're going to have division first. Let's do the numerator and the denominator. So we'll go ahead and do the 3 squared first. 3 times 3 gives us that 9 plus 1. And then we have that 3 squared, which is a 9 plus 1, and then squared. So let's simplify just the inside. We don't touch the square yet because we got to finish the inside first. We're going to have a 10 over 9 and that's going to be squared. So it means we're going to end up with a 100 over 81. So now, again, we have division with fractions. We go ahead and do keep, change, flip, KCF. So we're going to keep the 64 over 81. Okay, that's the keep. We're going to change the division to multiplication. And then we're going to flip the 181, and we're going to make that 81 over 100. Okay, and then we're just going to simplify from here. The 81s both will cancel each other out. Top to bottom reduces with fractions. And then for the remaining part, we're going to have 64 over 100, which we can reduce this. They both divide by 4. They divide by 2. Let's just keep simplifying until we can't. If I divide by 2, we get 32 over 50. If I divide by 2, I get 16 over 25. And then that's it. We can't simplify any further. This is our final answer. Okay. All right, on to letter C. We're going to be doing absolute value here. Remember, the absolute value implies that whatever number we get on the inside, it's going to turn into a positive value when we take the absolute value. Because remember, that's asking what's the distance from 0. So let's do the inside first. We have negative 4, absolute value of. And on the inside, we have subtraction here, and we have multiplication right here, right? So let's go ahead and do the multiplication first, because that's the first thing in our order. So we're going to minus 6 over 4, because the 2 just goes to the top there. It's going to be 2 times that, over 1/2. Okay. We have negative 4. And then, again, let's convert this so I can work with it, right? That 4 needs to have a denominator of 4 so that I can work with that 6 minus 4 that's there. This is, again, without a calculator. We're just doing this. So what number divided by 4 equals a 4? That's what we have to ask. What number right here divided by 4 is going to equal to 4? Well, that's going to be a 16, because 16 divided by 4 equals 4. All right, from here, we're going to have negative 4, absolute value of 1/2. This right here is going to turn into 10 over 4. All right, let's keep going. The next part is, how far is 10 over 4 from 0? Well, it's actually positive 10 over 4. Remember, that number, whatever it is going to yield a positive value. So it's just positive 10 over 4 divided by 1/2. So that's going to give us, when we do this, negative 4 times 10 is negative 40 over 4 divided by 1/2. We'll do keep, change, flip. And we have negative 10 times 2, which is going to equal negative 20. There you go. All right, next one. We're going to go through and do 2/3 squared minus 6/9. So let's do the exponent first. Please excuse my dear Aunt Sally. Parentheses and then exponent. So doing our exponent to the top and the bottom, we get 4 over 9 minus 6 over 9 divided by 4. That numerator is going to be just a negative 2 over 9 divided by 4. Okay, let's go ahead and try what we did earlier, the advanced method, right? You see how we have a fraction within the fraction right here? Let's get rid of it. Let's go ahead and figure out our LCD. Well, my LCD in this is just going to be 9. There's only one complex denominator, and it's that 9 right there. So if I was to multiply everything in this by 9, watch what's going to happen. The 9 times negative 2 over 9 is just going to equal negative 2. And then the 9 times 4 on the denominator is just going to equal 36. And if we reduce that, we get negative 1 over 18. There you go. All right, next, move on to number 5 here. Number 5, when we look at this, we're looking at substitution. Okay, so let's be careful. When you're doing these substitutions, you have to make sure you pay attention to the signs that are taking place and you use parentheses whenever necessary, okay? So let's look first at this x minus y minus absolute value of z. So for our x value, we're going to plug in a 3. For our, I'm going to keep the minus sign there because we have the minus sign in the original problem. Minus. For our y, we're going to go ahead and plug in a, we did 3 here. We're going to do 5 for our y value. Okay. And then we have minus the absolute value of, we're going to do, for z, we're going to put in negative 7. And then for z, we're going to put in a -7 on the bottom. All right. So orders of operation, let's do the top first. But since there's multiple grouping symbols, we'll do each one individually. The first part there, we're going to do 3 minus 5. So the 3 minus 5 is going to give us a -2. Then we have absolute value minus absolute value -7 over -7. I'm just going to do one thing at a time here. The absolute value of -2, remember, is saying, this right here says, how far is -2 from 0? It's 2 units away, so it's a positive answer right there. The next part right here says, how far away is -7 from 0? It's 7 units away. It's always going to be a positive value. And then we have that -7 on the bottom. If we continue simplifying, we have -5 divided by -7. Negative divided by negative yields a positive 5 over 7. There you go. Number 6, it says let a, and this is just a symbol saying that we just have plus, but the a plus b is equal to a squared over b squared for all the integers x and y. What that means is that any value we would have of x and y is always going to be the same. That if we have a plus b, it's just going to be, a squared over b squared. This is worded a little bit funny, I'm not going to lie. All right, so what does this mean? Well, when we look at this first part here at the top, you can see we have an a value, and then we have a plus, and then we have a b value, right? And what we say when that's happening is it's going to be equal to a squared over b squared, right? Well, if we look at the a value, it's going to be 10, and if we look at the b value, it's going to be -5. So if we square each one of these, 10 squared is going to give us 100, and 5, that -5 squared will give me a positive 25, okay? So if we get rid of these, we're going to have 100 over 25. Let's do it again for the bottom, okay? We have an a, and then we have that symbol plus, and then b. And then remember it's a squared over b squared is what it's going to equal, right? Well, in this case, my a value is -2, so if I square that, it's 4. And my b value is 3, so that squared is going to be 9. So that means if I replace these, we're going to have 4 over 9. Okay? And now let's go ahead and we can do keep, change, flip. All right, so if we keep, change, flip, we'll have 100 over 25. We'll change it to multiplication, and then 9 over 4. Let's simplify from here. These are going to equate to 100 times 100 over 9. Those hundreds cancel, leaving with just a 9. All right, last one. This is one where it's like I would pause it and test it out before you do it. But if you're ready to see it, just go ahead and continue. But what we're doing is we're taking the numbers 1, 3, 2, 5, and we're doing operations, whether it's parentheses or square roots, adding, subtracting, multiplying, whatever it might be. And we're going to see if we can get an answer of -6, okay? So pause it, try it. And if you're ready, just go ahead and move forward. All right. So what I did was I went ahead and I put parentheses around the first two terms, and I made it 1 plus 3. And then I put parentheses around the 2 and the 5, and I made it 2 times 5. And I put a subtraction in between. Now, what does that mean? Well, the 1 plus 3 is going to turn into a 4, and the 2 times 5 will turn into 10. So we have 4 minus 10, which is going to equal -6. And that is it, my friends. That is the end of our first lesson. If at any point during any of our lessons you're ever stuck, or you realize I went too quickly, or you just didn't write something down, feel free to always pause it, go back, and do it at your pace, okay? Until our next video, you guys take care and have a good one.